Okay, let's look at some of the 3.2 homework here. So in 3.2, we were looking at right triangles, and we were using our Sakatoa type stuff. So really what we need to know here is that sine is some old hippie comes around here, tripping on acid. All right, so that's opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. And remember, this is all based on, so the opposite and adjacent are based on whichever angle you're looking at, okay? Hypotenuse, of course, is always across from the right angle. The other formula we may need is that a squared plus b squared is equal to c squared. And that's, of course, our Pythagorean theorem, where c is always the hypotenuse. And then one other thing we might need to know is that the sum of the angles in a triangle is 180 degrees for our purposes. So knowing these things, we can pretty much do anything. All right, so let's check out some of these questions. All right, so the first one says, suppose, oh, well, I can't see what the question is. Hold on, let's scroll down. Okay, so it says, suppose we want to find exact values for these guys. Now, it does say exact values, so I don't even really need to, I can just type these right in. Sorry. Watch the angle. All of these are angle A. So for angle A is, little a is always its opposite. Little b is always its adjacent. So if we're looking for, now we also need the hypotenuse, don't we? So hold on, let's figure out that hypotenuse real quick. So 7 squared plus 12 squared will equal the hypotenuse squared, which they labeled as C. So that's 49 plus 144. 4 plus 4 is 8, is 9 is 1. So that's 193. And that is not a good answer as far as being a perfect square. Now 9, 10, 11, 12, 13. I don't think that has anything in it. Definitely doesn't have 4. It doesn't have a 9 in it. Doesn't have a 16. Doesn't have a 25. Doesn't have a, let's see if it's got 49 in it. No, I think we're just going to have to leave it like this. Oh, forgot that. Now, it is technically plus or minus, but we're talking about a triangle, so we're just going to leave it as 193. All right, so let's answer all of our questions now. So sine is opposite, which would be 7 over the adjacent, which will be the square root of 1, or sorry, opposite over hypotenuse. So there's that guy. Cosine is adjacent over hypotenuse. Right, tangent is opposite over adjacent. And now for secant, secant is 1 over cosine. So all I'm going to do is flip that cosine value. So 193, square root of 193 over 12. So secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is 1 over tangent. So see, all I did was use all of my reciprocals, and we're good to go. So again, recall that, get this up here. So recall that the secant of an angle is simply 1 over the cosine of that angle. Cosecant of an angle is 1 over the sine of the angle. And tangent of an angle can be thought of as sine over cosine. Oh, I didn't mean to say tangent, sorry. Cotangent of an angle can be thought of as 1 over tangent. So all you have to do is take the reciprocal of each of their pieces. So if you find those 3 first, then the other 3 are just their reciprocals. All right, so let's see. This one wants me to find pieces here. And it says, give all answers to at least 1 decimal place in degrees. All right, so I'm just going to go ahead and label the triangle on this one. So A is a 12, so that's a 12. This A is a 60. And notice that this is a 90, of course. So we can go ahead and fill in this other one. We know it's going to be 30 degrees. So see, this is going to be 30. It says give the answers to at least one decimal place. I doubt it's going to matter if I put the 0.0 on there, but do notice it already has degrees written. So we don't even have to use trig to do this one if you remember your special right triangles. B is the short side because it's across from the short angle. So whatever B is, this is always 2 times B, and this side is always the square root of 3 times B. Okay, so if 12 is the square root of 3 times B, that must mean that B is 12 over the square root of 3. So see, we can just do 12 over the square root of 3. It does want that in decimal form. I kind of just want to leave it. So 12 over the square root of 3. So this is about 6.9. And this is in, oh, it doesn't even say units. So just, we're not going to type that, but 6.9 units. And then based on B, we just double that to get the hypotenuse. So C is always 2B. So it's twice 12 over the square root of 3. So 24 over the square root of 3. But in our calculators, this would be 13.86. So those will be our answers. Oh, 1 decimal, sorry, 13.9. Actually, it said at least 1 decimal. So, all right, so let's just see. I kind of just want to leave them and see if it gets mad at me. Let's see if it gets mad. I just like exact values because I don't use calculators very often. Let's just see if it gets mad. It's not mad. Yay. Okay. So this one's very similar, except you have to use trig on this one. You can't do the 30, 60, 90. So in that last one, if you're just not comfortable using the special right triangles, just look at this one and you'll see how to find them using the trig. The trig? Haha, the trig. Okay, and so they gave me C and A. And now remember, the whole thing's got to add up to 180. So we know that the right angle is 90. That leaves us needing 90 more. We've got 65. So that leaves me with 25 degrees. So B must be 25 degrees. Now that I've got that one, we can find these other sides. Now, notice I can't use the Pythagorean theorem because I only have one side of the triangle. But let's look at A. We can do, now we have options here. We could do sine of 65. Sine is opposite over hypotenuse. Opposite, yes. So we could do that, in which case A would be 5 times the sine of 65. Or you could do cosine of the B. Cosine is adjacent over hypotenuse. So notice you would get 5 times the cosine of 25. Either of these will give it to you. So whichever one you want to do, it doesn't really matter. I'll just do sine. And then for B, you can use another trig function if you want, or, and actually you could use sine, cosine, or tangent to find this, or you could do the Pythagorean theorem. So it doesn't really matter. I guess I should figure out what that is. Make sure your calculator is in degrees. Mine is in radians. Okay, so I just switched my calculator over to degrees, and I'm going to do 5 times the sine of 65. So this is about 4. Oh, sorry, I was in eraser mode. Okay, this is about 4.53. And so now again, we could do 4.53 squared plus b squared equals 5 squared using the Pythagorean theorem. Or we could do, say, the cosine of 65 degrees is equal to b over 5. That's a b, that's a 5. Or you could do the sine of 25 is equal to b over 5. Or you could do the tangent of oh, hell, either angle. So actually, oh, there's so many different ways to do this. Tangent is opposite over adjacent. So you could do tangent of 65 is A over B, or just for the heck of it, let's see, you could do tangent of 25, which would be opposite over adjacent. And so solve any of those. I don't know. You know what? Why don't I'll use this one. So I'm going to say that this is 5 times the cosine of 65 degrees. So 5 times cosine of 65. And again, I don't care how you find it as long as you show me your work. So either write this down, this down, this down, this down, this down. I don't really care. Okay, so let's put these answers in and hope that I had the right decimals here. It says at least one. So we can do, okay, A, I believe, was 4.53. B was 2.11. And this B, that's for the angle, that was 25 degrees. Yay. All right, so now, okay, these are all the same questions, you guys. I don't want to do all of these. How about, is there one without a picture? Let's do number 5. So let's look at number 5. So it's all about these word problems. It's all about reading it, drawing a picture, reading it again as you label, and then as soon as you have your picture, it's just like all these other questions. So it says the angle of elevation to the top of a building in New York is found to be 2 degrees from the ground at a distance of 2 miles from the base of the building. Okay, so here's my building. I swear that's a building. There's the door. Okay, I am 2 miles away from the building. Oh. Okay, I should have made my building much shorter. I'm going to make it shorter. Here's my tiny building. Okay, because it says the angle of elevation. Remember, angles of elevation or depression are always from a horizontal. So in this case, the horizontal is the ground, and it says that this is 2 degrees. It says I'm 2 miles from the base of the building, and it wants me to find the height of the building. And oh, look, they want the answer in feet. So I'm just going to find it and then convert it over to feet. So for right now, look, it's just a triangle. We have, technically, we know that this is what, 88 degrees, because it's got to add up to 180. We've got 92 already. Oh, whoops. That is not 88 degrees. That is 78 degrees. No, that is 88 degrees. Okay, leave me alone. All right, so that's going to be 88 degrees. But it doesn't really matter. Why don't we just, if we use this angle, he is his opposite and he is his adjacent. So who uses opposite and adjacent? That would be tangent. So the tangent of 2 degrees will be equal to the opposite, which is the height of the building, divided by the adjacent, which is 2 miles. So that means that h is equal to 2 times the tangent of 2 degrees. Make sure you're in degrees. So 2 times the tangent of 2. So I get that the height is 0.0698. But this is in miles, which is kind of a weird thing to talk about a building, right? So we know that that 1 mile has 5 tomato feet. So I'm going to multiply this answer just in my calculator. I had it still in my calculator, so multiply that, I get 368.76 feet. So that's how tall the building is. But again, it's all about reading, drawing a picture, reading again, label the picture, and then it's just a right triangle that you can answer. So we ended up with 368.76. Again, it said feet, so be very careful. Now, let's look at this. Well, that's a 30, 60, 90. What about this one? Let's look at this one, just because it's a little weird. It's got like a big triangle with a little triangle on the inside. This is going to be very similar to that very last one I just looked at, except that one's a 30, 60, 90, so it follows those rules. So this one really just wants me to find x. So let's kind of think about this. First off, this is a straight line. Straight lines have 180 degrees on them. So that means that both of these are 90, 90 on the right, 90 on the left. That also means I can find the other angles. So 180 minus 90 leaves me with 90, minus the 31. 8 minus 3 is 5. So that means this one is 59 degrees. So now I can use, oh, I guess I didn't need that, did I? Whatever. I can just use this to find this piece. Yeah, I didn't even need to figure that out. We're just looking for x. So based on this angle, who uses opposite and adjacent? So that would be tangent, right? So if I do the tangent of 31 degrees, I will get opposite over adjacent. I don't know what that is. I'm just going to leave it as a question mark for now. So notice, to solve for this, they swap places, essentially. You get 86 over tangent of 31 degrees. You can cross multiply and then divide to see that. But I'm just going to put this in my calculator. So 86 divided by the tangent of 31 degrees. This means that my question mark is approximately 143.128. So this side is 143.128. That's not what they want. They want the whole thing. So now I'll come over to this second triangle and do the same thing I just did. From this angle, I know opposite and I need adjacent. So I'm going to do tangent again. Let's call him a question mark again. So the tangent of 44 degrees would be equal to his opposite over his adjacent. So same thing. That question mark is going to be 86 over the tangent of 44. So 86 over the tangent of 44 degrees gives me 89.0556. So I'm going to do 0.056 just to get 3 decimals. And now I'm just going to add those together and I'll have x. So that answer plus the 143.128. So add these together and you'll get 232.184. We'll do 4. And that is probably not what I would have gotten if I just added my 2 3s. Yep, 232.184. All right. So it looks good. And this one was just units. It didn't have anything specified. And so now again, on this last one, you're going to kind of do the same thing, but it wants you to find all the different pieces. But you can use trig here, or you can just use the special right triangles. So you know that this one's 60, you know that this one's 30. It tells you up here that AC is 5 square root of 2. So that's the hypotenuse. Here's the short side. I'm going to call him B. Short side's across from 30. Twice that is always the hypotenuse. You see, so that means that B must be 5/2 square root of 2. So this is 5/2 square root of 2. To get to the long side, you simply multiply that by the square root of 3. And notice that would be the square root of 6. Okay, so now we've got this side. And then for this one, you can do the same kind of thing. This is the short side right here. So let's call him, I don't know, how about S for short? I guess he's called DB, but whatever. So we know that, and so what we have then is the long side. you see. So the long side is always square root of 3 times the short side. So see, if you divide that by square root of 3, you'll get S, etc., etc. So anyway, so that is this homework. So again, with those word problems, just read them, draw a picture, and you'll have a nice right triangle that you can use trig on.